Section 5.3, graphing radical functions. We're going to start with a vocabulary term. That would be radical function, and the definition is going to blow your mind here. It's a function that contains a radical. I know, that's just an outrageous definition. A radical function is a function that contains a radical. We're going to be talking about radical functions just so we have an understanding of what radical functions are. I've got one right here on the screen. F of x is equal to the absolute value of x. It could be cube root of x, which we're going to get to next. Fourth root, fifth root, sixth root, 10th root, 100th root, whatever. Okay, anything with a radical is considered a radical function. So what I want to show you the two main shapes of radical functions. You can kind of lump them into two categories. You can talk about even degree radicals and you can talk about odd degree radicals, and they have the same general shape no matter if it's second, like square root or fourth root, or third root and fifth root. They're going to look very similar. They're going to have the same shape, but the numbers are going to be a little slightly different from one graph to the next. But the shapes are going to be generally the same. So we're going to start with f of x is equal to the absolute value of x. And when you graph this, I would prefer that you make an xy table. So xy. And then could you use your graphing calculator to get some values and just go like 0, 1, 2, 3, 4? Sure, you could. But I want you to think about in terms of what numbers work or what numbers give you good results when you put them underneath the square root. Okay? The smallest number you can put under the square root is 0. You can't put you can't find a real answer when you put a negative under there. So the smallest x value I want you to use is 0, or the smallest x value you can use is 0. Okay, the next largest perfect square would be 1. The next one after that is 4, and the next one after that is 9. Okay, so how do we find the y values? Well, just like with any function, we're going to take these x values and we're going to plug them in. So the square root of 0 is going to give us 0. The square root of 1 is 1. The square root of 4 is 2, and the square root of 9, is 3. Okay, so that's those are the basic, the first 4 points of our function that give us nice whole number x and y's. Could you do, like I said, could you do 2 and 3? Sure, you're not going to get great numbers here, and you can use your calculator to do that. But I would prefer to see these whole numbers here so you do get these nice results. So if we were to graph it, and let me actually bring in some graph paper here, turn that to graph paper, and we can make it. We can kind of graph and see what this looks like. So here's my x or my y-axis. Here's my x-axis. These are going by ones. So we got 0, 0. We have 1, 1, which is right there. We have 4, 2, which is there. And then we have 9, 3. So 5, 6, 7, 8, 9, 2, 3, 4, 5, 6, 7, 8, 9. 3 would be out in here. Okay? And our function goes this way. It's kind of a sideways parabola. Okay? Now, the question becomes, can I put an arrow on the end of this side, the left side? Can I put an arrow right there? And the answer here to that is no, because like I said, you can't put negative numbers underneath the square root. Okay, if we put an arrow under here or on the end of this, that implies that we can put negatives or that the function continues forever in the left direction, and that's not true. Okay, so you do not put an arrow on the left side of an even radical function. Okay, keep that in mind. That might be something to write down. Okay, only one arrow and it always goes out to the right. Okay, just a couple of quick notes with even functions. All even radicals have this shape. Okay, one of my high school math teachers called this a ramp, and it kind of makes sense. It kind of looks like a pitcher's mound in baseball. All even radicals have this shape, whether it's square root, fourth root, sixth root, 10th root, 100th root, millionth root, whatever. They're going to have the same general shape. It's going to be a ramp. Now, how flat it is depends on if it's a square root or a fourth root or whatever. Okay, but all even radicals are going to have this shape. So that's one little bullet point to make off to the side. The next one, we need to talk about the domain and range. So the domain of an even radical. Okay, like I said, we can't use negative numbers here for our x value because we can't take the square root of a negative number. So the domain here is going to be x is greater than or equal to 0. Okay, and then for the range, if we look at our picture, the lowest we get is 0. We're not going down any farther. The lowest we get is 0, and eventually we do go up forever. It's up very slowly, but it is up forever. The range here is going to be y is greater than or equal to 0. Okay, so that's the basic general shape of even radicals. Let's look at odd radicals. So we've got the cube root of x. G of x is equal to the cube root of x. And once again, we're going to make an xy table. I'm going to make 5 spaces this time. xy, 1, 2, 3, 4, and 5. Okay, now, Can we put negative numbers underneath an odd radical? The answer to that is yes. If you go look at that table from section 5.1 way at the beginning, you can take the cube root of a negative number. We can take the cube root of -8 or -1 or -27 and get get an answer, basically. Okay, so what I would suggest, let's put 0 in the middle of this one. The cube root of 0 is 0. Okay, the next largest perfect cube would be 1. The cube root of 1 is 1. The next largest cube after that is 8. And then when we take the cube root of 8, we get 2. Okay? If we go in the negative direction, we can have -1. That will give us a cube root of -1, and then -8 gives us a cube root of -2. So we can go ahead and graph this. Let me see. I'm going to need enough space here. I'm going to go pretty long here. And right there, we'll see if we got enough space. So we got 0, 0 right in the middle. We'll have 1, 1. We will have -1, -1. We have 8, 2. So 2, 3, 4, 5, 6, 7. I'm just counting out loud here while I'm air penning. There's 8, 2, and then -8, -2, 2, 3, 4, 5, 6, 7, 8. -2 is right there. So our picture looks something like this. It's kind of, we got this, and it turns upwards, and then it flattens out again. Okay, so you can kind of think if you turn this graph sideways, this would kind of look like the cube root function, or not the cube root, the cube function, the cubic function, y equals x cubed, and we'll get into inverses and all that good stuff later on in this trimester. But this is the basic shape for odd radicals. Okay, it might be a little flatter, might be a little narrower, but this is the general shape. So we can make a little note off to the side here. All odd radicals have this shape. Okay, and notice I put an arrow on both ends because we can have positive numbers under the cube root, we can have negative numbers under the cube root. With this one we couldn't have negatives, so we don't put the arrow on the left. With this one, since we can have negatives underneath the cube root, we can go to the left forever. So keep that in mind as you're drawing your picture. Odd radicals are going to have 2 arrows, even radicals only have 1. The domain here, the domain for odd radicals is all real numbers. We can put any number under there and we're going to get an answer. The range is actually the exact same thing. We're going up and down slowly, going from 1, and then it takes us forever to get to 2. It would take us even longer to get to 3, but eventually we would get to all of the y values, and then same thing on the bottom side. Okay, so the domain and range for odd radicals is all real numbers for both. Let's talk about the transformations of radical functions. A big part of the first trimester was transformations of functions, and the rules here are pretty much the same thing. Your a values in either the square root or the cube root represents your vertical stretch or shrink. Vertical stretch or shrink. And you might want to put a little note here, if negative, and we'll have an example here in a second, if negative, that's a reflection as well. Reflection in the x-axis. Okay? If the a value is negative, if this number out front is negative, it's a reflection in the x-axis. So if we look at this one, it would go something like this if the number out front was negative, or this one would go this way. Okay? Everything for, especially for even radicals, this one up here, this is always going out to the right. We're never going to have one that goes back out to the left. Okay, so keep that in the back of your mind. Vertical stretch and shrink, if it's negative, it's a reflection in the x-axis. The h value, just like with the quadratics, the h value represents the horizontal translation. Horizontal translation, that's the shift or the slide. Horizontal translation, remember the directions are opposite. So if it's +2, that actually means to the left. If it's -2, that means going to the right. And then your k values, the numbers on the end, that is your vertical translation. Just like with the quadratic functions from chapter 3, the number on the end tells you how far up or down to slide the thing. And the directions here are normal. Okay, there's no funkiness with it. Plus means up, minus means down. So let's talk about describing the transformation from the graph of f to the graph of g, then graph both functions. So if we have f of x equals the absolute value, or not the absolute value, square root of x, and g of x is equal to the square root of x plus 2 minus 3, the question becomes what changed from this one to this one, because it says from the graph of f to the graph of g. Well, from this one to this one, we have 2 different changes. We have the +2 underneath the square root, and we have the -3 on the outside. So to me, these are both translations, because if we look back up here, we don't have anything outside. Okay, so there's no vertical stretch or shrink, so there's no reflection, so we just have a horizontal and a vertical translation. So we'll just say it's a translation. If we talk about the 2, that's 2 units, and that's a horizontal, and that's backwards, so plus 2 is to the left. And the minus 3 on the end tells us to go down. Okay, translation 2 to the left and 3 down. Now when we graph this, let me bring in some graph paper again. Let me draw this in. We have square roots, so we don't really need much of a negative x-axis. We'll have this. This is fine. We already know what the square root of x looks like. If I wanted to make an xy table, I could. I'll do this one vertically. xy, the smallest one was 0. That gave me a y value of 0. 1 gave me a y value of 1. 4 gave me a y value of 2. And 9 gave me a y value of 3. And that's more than enough points. So we have 0, 0, 1, 1, 4, 2, and 3, 9. Okay, this would be this function right here. This is f of x. Okay, now we need to be able to graph g of x, we just need to follow our directions. I'm going to do this in orange here. Okay, so go 2 left and 3 down. So from this point here, we're going to go 2 left and then 3 down. So my point is going to be right here. And I'm going to do that with all of the points. So for 1, 1, we're going to go 2 left and then 3 down. So that will get us right there. Okay, and then do the same thing with the other points. 2 left, 3 down gets you right there for 4, 2, and then 2 left and 3 down puts you on the x-axis for the next one. And we can draw our curve once again. Again, we're still not putting the arrow on the left-hand side because this is an even function, an even radical function. And that's all there is to it for number 1 here. For number 2, we got a couple of different transformations. We deal with the negative first, okay? That tells us that it is a reflection. It's negative, so we have a reflection in the x-axis. Okay, that's what the negative tells us. And then, let me switch to green here. The 2. Now, we didn't have one that looked like that in our information up here. But if you remember from your rules, anytime you multiply x by something, that's either a horizontal stretch or shrink. Okay, every time it's directly to x, it's horizontal. So it's a horizontal. We're multiplying, so that means it's a stretch or shrink. We'll come up with the stretch or shrink here in just a second by a factor of what? Well, remember, if you remember the rules, every time you multiply x by something, that is the reciprocal of the factor. So if we're multiplying x by 2, the factor then is 1/2. And if the factor is 1/2, that means that this is not a stretch, it is a shrink. It is a shrink by a factor of 1/2, which means every point gets half as close to the y-axis as it originally was. So if I were to make an xy table of this one, we already know what that one's going to be. I'll do that here, do it vertically again. xy, we had -8, -1, that's a 1. Let's try that again, 1. And then we had 0 and 1 and 8. This gave us -2, -1, 0, 1, and 2. So when I graph this, let me move this down just a little bit. Let's see. Hopefully I've got enough room here. If I graph the original one, 0, 0, 1, 1, 2, 3, 4, 5, 6, 7, 8, 2. And then I have the same picture going the other direction, 2, 3, 4, 5, 6, 7, 8, -2. So this is f of x. Whoa, let's try that again. F of x goes like this. Okay, this was f of x. Now g of x, I'm going to do in orange. Let me switch to orange here. I'm going to follow these directions in this order. I'm going to do the reflection in the x-axis and a horizontal shrink by a factor of 1/2. So reflect it. So I'm going to start here. Reflect it in the x-axis. So if it's 2 above, it'll be 2 below. And this is 8 units away from the y-axis. So shrink it by 1/2. 1/2 of 8 would be 4. So I'm going to go to 4 in, 1, 2, 3, 4. It's going to be right in here. So this point translates or transforms into this one. So these two are paired together. If we look at this one right here, reflect it over, so it's 1 above, so it'll be 1 below, and then a horizontal shrink by a factor of 1/2. So it's 1 unit away from the y-axis, so 1/2 of that is just 1/2. So it's going to be in between 0 and 1. The point on the origin, 0, 0, if I reflect it, it's not going to move, and then the distance from the y-axis is 0, and 1/2 of 0 is still 0. So really, the point on the origin isn't going to move. We haven't translated that at all. or transformed it. We have, but it doesn't look any different. Let's put it that way. This point right here, 1 unit below. When we're reflected, it would be 1 unit above. And then we cut the distance in half, so it's 1 away from the y-axis. So that would be half away when we cut that distance in half. And then the last point over here, it's, let's see, 2 units below, reflected to 2 units above. It's 8 units away from the y-axis, so now it's going to be 4 units away. So 1, 2, 3, 4, 1, 2, 3, 4 be right in here. So this point transforms into this point, and then we have our curve. A little narrower and a little taller. Okay, so there's a couple of examples of graphing transformations. Let's talk about writing transformations now. If I say let f of x is equal to the cube root of x, number one, let the graph of g be a horizontal shrink by a factor of 1/6 followed by a translation 3 units left. Write a rule for g. So now we're going to go from, so like in this one, I gave you the function, you tell me the transformations. Now we're going the other direction. I'm going to give you the transformations. You tell me what the other function is going to be. And we have to follow this order. Horizontal shrink by a factor of 1/6. Remember, horizontal means we're going directly to x. Shrink means we're multiplying x by the reciprocal of the factor. So we can start with saying g of x is equal to, we still have the cube root. X is underneath, so we're going to do everything underneath here. The factor is 1/6. That means we're going to multiply x by 6. So we're just going to say 6x. That's what this does. Horizontal shrink by a factor of 1/6. Now we need to do followed by a translation 3 units left. I'll do that in a different color. We'll do that in green. So translation 3 units left. Anytime we're translating, we need to do it directly to x. Now, what I see a lot of people do is they'll just extend this and make this plus 3. And you would be incorrect here because this would be adding 3 directly to 6x, but we need to add it directly to x and only x. So what we're going to do to combat that, we're going to say this is equal to, let me go back to the pen, equals cube root of 6. Now there is x, and we're going to do this directly to x, so we need to put it in parentheses. X, now 3 units left. Translation means we're going to add or subtract. Directions horizontally, left is horizontal, are backwards. So normally left we would have to subtract on the number line, but we're actually going to add. So x plus 3. Okay? Now, if you want to leave it just like this, I'm okay with that. If you want to distribute this, because that's really pretty simple, you can do that as well. We can say g of x is equal to the cube root of 6x plus 18. Just take 6 times x and 6 times 3. And that would be your answer there for number 1. Cube root of 6x plus 18. Question number 2 then says, is the rule the same if you reverse the order of transformation? So if we do the adding first and then shrink it, are we going to get this answer in return? Okay, so let's think about this. We start with the cube root of x. The first thing we need to do is translation 3 units left. So we'll say g of x is equal to the cube root. So now we're starting back with this one again. We're starting back with the original one. Translation 3 units left means we need to add 3 directly to x. And the only thing underneath the radical was x, so we can just put the plus 3 underneath the cube root. Now we need to do the same thing we need to apply the other transformation, which was the horizontal shrink by a factor of 1/6. Again, that means multiply x and only x by the reciprocal of the factor. So we're going to multiply x by 6. So only x gets multiplied by 6. So our answer here is going to be g of x is equal to cube root, there's x, so multiply it by 6, plus 3. Are the answers the same? No, not the same. So the order in which you transform these functions does matter. Okay, so our answer here for this one, we go back to the pen, is this. These are not the same. They're close, but they're not quite the same. Okay, so just keep that in mind. When you're being asked to write transformations, you need to do them in the proper order. All right, I have one story problem for you, and then we'll call her good here with this video. The function e of d is equal to 0.25, and I forgot to add this when I made this, when I formatted this. E of d is equal to 0.25 times the square root of d, approximates the number of seconds it takes for an object to fall d feet on Earth. The function s of d is equal to 4.4 e to e of d, approximates the number of seconds it takes for an object to fall the same distance on Saturn. Question number 1, write a rule for s. Well, we know it tells us, the setup tells us that s of d is equal to 4.4 times e of d. So s of d is equal to 4.4 times e of d. Well, what is e of d? E of d is told to us right there. So we can put this right there. So we'll make this 4.4 times, and we'll just do this in parentheses, 0.25 times the square root of d. Now, can we clean anything up? We can multiply these two because this is 4.4 times 0.25 times the square root of d. It's all multiplication, and you can multiply in any order. We do know how to multiply 4.4 and 0.25. What that's going to give us, and we'll just stay here in green, is equal to 4.4 times 0.25 is equal to 1.1 exactly. So 1.1 times the square root of d. And this is your answer right here. S of d is equal to 1.1 times the square root of d. So we have a lot of words in our setup, but really there's not a whole lot to do here for number 1. Question number 2 then says, how long does it take an object to fall 15 feet on Saturn? Well, d is our distance, and we are given a distance. So all we're going to do is we're going to take this 15 feet, and we're going to put it in for our distance. So we're going to say S of 15 is equal to 1.1 times the square root of 15. And this is something you can type in your calculator. When you get this, we can say it's going to take approximately 4.3 seconds.